In this video, we will be going over different questions related to dot products, and yeah, so this is going to be a bit harder than the before ones. This is part 3, so be sure to watch part 1, the fundamentals of dot product, part 2, example problem. So let's start. So the first question, we will be finding the dot product of these two unit vectors. So as you know, the first thing that we need to do is find their magnitudes. So the first thing that we need to do is multiply their respective components. So 4 times 3 is going to be 12 plus 2 times minus 5 is going to be minus 10. 10, which will be equal to 2. So the dot product will be 2. So the next question, we will be finding the cosine angle between two vectors. So to find the cosine between these two, the first thing that we need to do is find their magnitudes. So using the Pythagoras theorem, you can find the magnitude of both vectors. And the next thing we need to do is find their dot product. So using the same process that we did for question 1, we can find the dot product as 7. Then remember the formula. Cos theta equals to u dot v over magnitude of u times magnitude of v, which equals dot product is 7, and their magnitude is 5 times 5. 7 over 25 will be the cos theta. So please, before I do the questions, you can try them on your own, and then you can follow along so you know that you understand the topic better. So the next thing we're going to do is we're going to classify vectors as orthogonal, parallel, and neither based on their dot product. So the given vectors are the following. These are the vectors. Please feel free to pause the video and try them on. So let's do them together. The first thing that we need to do is multiply the respective components. So minus 5 times 6 is going to be minus 30, plus 3 times minus 8 is going to be minus 24, which will be equal to 54. Minus 54. So this is not equal to 0, so this is neither. So the next one is going to be minus 1 comma 1 over 2, and v is going to be 3 comma 6. So let's multiply the respective components. So minus 1 times 3 is going to be minus 3, plus 1 over 2 times 6 is going to be 3, which is going to be 0. So 0 is obviously equal to 0. So as you remember, if their dot product is 0, then it's orthogonal or perpendicular. Firstly, we're going to repeat the same process. 2 times minus 3 is minus 6. And 6 times minus 9 is going to be minus 54. So this is going to be equal to minus 60, I believe. But one step I forgot is we need to make sure that the dot product is not equal to the product of their magnitudes, because if that is the case, then that is not neither orthogonal or perpendicular, but that is actually parallel. So for this one, let's check if the product of their magnitudes is equal to the dot product. And their products will be 60. So these two are actually anti-parallel. So this is because one of them is negative and the other is positive, which gives it away that it's actually anti-parallel. So that's how you know that the vectors are parallel, orthogonal, anti-parallel, or neither. So the next question has is that show that u minus v times eu plus v is equal to u squared minus v squared. This is really easy to show that it's actually true, because all we need to do is just expand this particular multiplication. So u times u is going to be u squared, u times v is going to be plus uv, v times u is going to minus v times u is going to be minus v dot u, and then v times minus v times v is going to be minus v squared. So as you know, dot product is commutative, so these can't cancel each other out, which will give us u squared minus v squared is equal to this. So guys, this is how you can show that this particular statement is true. So our next question, we are given the following, and I want you guys to give this a try, because this is just the most important question that you need to answer in order to get how much you understand this particular topic. So give it a try, then come back. Feel free to pause. Okay, now let's do this question together. The first one is pretty easy. We just need to plug in the numbers. U dot v equals magnitude of u is 5, magnitude of v is 12, and then cos 120. This will give us minus 30. B. Now, this one is kind of tricky, and we need to expand it a little bit to understand how it actually works. So let's expand it together. I mean, we already did expand it over here, but let's do it again for better clarification. So here u squared minus, plus u dot v minus v dot u plus v squared. So this is how we can simplify it, expand it. Now, we need to plug in the numbers. So u squared is obviously going to be the magnitude of u squared. So we're going to plug in 5 squared, which is 25. Here, these ones cancel each other out. And here, we're going to square 12, which is 114, which will give us 119, I believe, minus 119. This is, over here is minus, so this is going to give us minus 119. So 25 minus 144 is going to be minus 119. C is practically the same thing, but it's different when it's expanded because there are some things that don't cancel out, which we will see right now. U squared u dot v plus u dot v plus v squared. As you can see, we have two u dot v's. So first the square u, which is 25, plus twice of u dot v plus 144. So twice of u dot v, we already got u dot v here. So 30 times 30 is going to be, 30 times 2 is going to be 60. So it's going to be minus 60. 25 plus twice of minus 30 plus 144, which is going to be 25 minus 60 plus 144, which is going to be equal to 109. So guys, I am leaving this D as an exercise for you, but this is the final answer right here. So please put the procedure or the steps you took in order to get to this answer in the comments, or you can do it on your own. So now let's do the final question. So we are given these vertices of triangles, and our main goal is to find angle BCA. So please do this on your own. I'm gonna give you guys a few seconds. So first, let's try to visualize this particular question. So this particular triangle. So this is going to be C, because as you can see, this is C in the middle. So it's going to be 4, 6. This is going to be A. Its vertices is going to be 1, 5. And this is B. Vertices 2, 2. So the first step that we need to take is define the vectors. So the vector CB and the vector CA. So in order to do this is we just need to subtract componentes of B from componentes of B minus A, pretty much. So, and then it's going to be A minus C. So these are going to be our vectors. Now we need to find their dot product. So their dot product will be CB CA, which will be equal to the multiplication of their componentes. -2 times -3 is going to be 6, plus -1 times -4 is going to be 4, which will be 10. So this is their dot product. Now we need to find their magnitudes. Now let's do the formula. So it's going to be CB dot CA over magnitude of B and magnitude of A, which will be the dot product is obviously 10 over root 10, and then 2 times root 5, which will be simplified to 1 over root 2, which will be root 2 over 2. When we factorize it, this is root 2, this is root 2, so it's going to be root 2 over 2. And as you know, the cos theta value for root 2 over 2, or the angle value, is 45 degrees.